Good morning, everyone. John Grimsmo here. Today I'm driving to just outside of Toronto to the Elliott Matsuura Joint Open House. Now what that is, it's where 5 CNC machine tool distributors get together and basically open their doors and turn on a bunch of their machines and let people come and check them out. So I went to this event in 2012, 2 years ago, and I didn't get to go last year, but in 2012 I did do a video of that and I put it up on my YouTube channel, so check that out if you didn't get a chance to see it. But yeah, this year I'm going again, and like I said, it's been 2 years, and in the past 2 years I've learned a lot more about CNC machining and about the industry in general, so I'm really excited to go back this year and hopefully learn even more. The Tormac machine that I have now and some of the other stuff, it's more in the affordable price range, you know, the stuff that I can actually afford. The stuff I'm going to look at right now is way beyond my budget, but it's always really fun to look at, and I get to learn some really cool things just by looking at it and, you know, maybe applying some of the technologies to what I'm doing now, just on a lower end. It's kind of like, you know, if you're a car guy and you go to a car show and you get to look at Lamborghinis and Bugattis and all your favorite stuff, you're never going to be able to afford one, but it's awesome just to look at anyway. So if you're into CNC machining, or even if you're just somewhat interested in manufacturing, this should be a pretty cool video for you. And the things that I learn, I'll try to pass on through the video, and we can learn together. So I should concentrate on driving, but I should be there pretty soon.
Stats and stuff, it's all in the system. With the next part, you just press this way, and you might just record next one, press start. So it's
there's a radius around all the pieces, and I'm actually 5-axising the rad on all the puzzle pieces. That's all it's doing right now. It's just going around. Now the radius I could easily just 3-axis,
yeah,
but I didn't want to. I wanted to show it cut in 5. So some of the design changes they made this year is they made the door on a slant. Before the door just stopped right here. Yeah. So it was hard to reach in and look at the piece, but now I can just simply walk in, I can look at the piece.
Yeah, much easier.
Very accessible. This is a laser. We have an end probe that pops the laser out. You measure the tool lengths.
Okay.
For the tools. Tool changers down there.
Is there not 2 sides to the laser? Like,
yeah.
You know what I mean?
Well, your laser comes out.
Oh, it comes out of there.
It comes out. So there's always a laser and a receiver.
Right, I figured.
Yeah. Great machine. It's got the matrix tool changer on it. So the matrix tool changer, so because you have so many parts, as soon as I open and close the door, the light will put on. It's like that.
Yeah.
So you got 32 pallets, and because you have so many pallets, you have the matrix tool changer. So the matrix tool changer, we can just buy the trees. And it comes with, I believe it's 4 or 5. I think standard's 160 tools. But then you can just buy these, and you get up to 320 tools. Jeez. Because a lot of times you might be even cutting very hard materials. So you might want to put in that's called sister tools. Yeah. So let's say you have a part, you know that particular end mill right there will only last 10 parts. So now you're going to have maybe 20 of those end mills. The exact same end mill, but every 10 pieces it grabs the next end mill. So it's sister tool.
So these do they move at all or no?
Oh yeah, if I call up a tool, that arm right there will grab it, swing it over to the tool change arm.
But the racks don't move?
No, the racks don't move at all.
Yeah.
Nope. And the Cublex, you can actually turn. So this one here, you can actually turn and mill like a lathe.
Wow.
Yeah. This is called a mill turn machine.
Yeah, that's a nice finish on it.
Yeah. It's a great machine.
Where's all the action happening.
Through there would be better. Better shot. Put this one away. And then grab the other one.
So just put that one back, and now it's going to grab this one. So you load the part here, I guess.
Normally, yeah, that would be
Your
a
work
load
piece,
and you'd say it's ready, store it, and then we'll do the next one that runs.
And it holds it down just kind of like a drawbar.
Exactly. It's a capped out connection, so it's kind of a weird triangle
Okay.
sort of configuration.
So it doesn't rotate
And
like
then
that.
2 pins so that it can only go in one way.
Yeah.
So if you need like a time sort of
Yeah.
fixture, you can't put it in backwards.
Makes sense.
Well, yeah, I'm waiting for flights. What was supposed to
That's just cool. What material is it?
That's the plastic,
The plastic, okay.
color. So it's like a powder plastic.
That's
Same as this one. You just find the page here.
Alright, so I'm at the Widia. Did you say it?
Yes, Lydia.
Widia. Alright, so I'm at the Widia booth learning about end mills.
So we have, this is our kind of our more of our general purpose end mill series, which is for all different materials. We call it our Vari-Mill series, 5 flutes.
Variable flutes.
Variable flutes, exactly. And, we have for a primary and secondary relief, which is common relief for end mills. What we have with our Vari-Mill 2 ER stands for eccentric relief. What it has here, it doesn't have a primary and secondary anymore. It has one straight eccentric relief. What it does is it creates stronger cutting force that actually impact of the cutting edge.
Okay.
Rather than having the primary and secondary relief.
Yeah.
So that's the main benefit with this titanium milling. We also have button insert, where we have grades that are strictly designed for titanium. So it's a negative insert, but with a sharp positive design in the chip breaker.
Okay.
And it's double-sided, so you get 6 cutting edges per insert. And really, you probably wouldn't use anything like this, but this is...
I can't even think about using that.
It's also for titanium.
Yeah?
Yeah. So
Without a coating or anything?
Without a coating, and it's high-speed steel. It's not carbide.
Okay.
So sharp has chip breakers in there for for breaking up chips, and no more for heavy hogging of titanium.
Yeah, that'd be some heavy hogging.
Yeah, exactly.
Wow.
Exactly. This is awesome. Like, what would one of these go for?
They start at 500 and they go up from there.
500.
Yeah. Well, I gotta afford all these expensive tools. I mean,
Wow. And have you designed these all yourself?
yeah.
Yeah.
Yep.
How many of these would you make?
I've made over 200 so far. Wow. Still going strong. So of course, as I'm here, I'm showing everybody my knife just because everybody gets a kick out of it. Well, that was pretty awesome. That was the first location that I went to, Elliott Matsuura. And I spent probably 2 hours in there, had some good lunch. They had a really good spread of all kinds of burgers and hot dogs and good stuff. Really nice talking to all these people. I sat down for lunch with a guy who rebuilds spindles. He's been doing it for 25 years, so I actually picked his brain about spindles in general and the things that I know, and any improvements that I could make to mine or check for wear or whatever. And he gave me some really sweet suggestions about how the spindles taper together and how to use bluing compound on the surfaces, and then you put them together and you see where the wear spots are. And we talked about run out and all kinds of stuff, and it's really cool just to go to one location with all these people that are they're there to talk. So I realized, I'm there to ask questions, let them talk. So learned a lot of really cool stuff. And just the question always comes up, oh, what do you do? And I've got my Grimsmo Knives t-shirt on, so I get to pull out my knives and show it to them, and probably pulled out my knives 12 times or whatever just talking to these guys. Everybody is super interested in what the heck I'm doing, and they're used to big business that just is job shops. So they take an order in and they make it, whatever it is. They're not used to little guys like me working out of their garage. They get such a kick out of it, seeing the level of quality of work that I can do just from a small affordable machine just in my garage. It's so much fun to give them a kick. Yeah, it's really cool. I don't want to say it's an ego boost for me, but it kind of is, because it reinforces the fact that I'm really happy with what I'm doing right now, with the business and with how things are going. And I'm proud to come to a place like this and talk about my work and my business and show off in a way. And I think I got a few orders. Yay! So it's funny because these guys are selling $500,000 equipment, and they kind of gasp at the $500 price tag for my knife just because they're not used to it. They think a Walmart knife is $20, but it's kind of funny to get them shocked for a $500 knife. And then I ask, well, the software you're selling is 10 grand. What are you complaining about? Anyway, off to the next place. I think we'll hit up DMG. They make some really cool stuff too.
This is either air or hydraulic. You shoot it with a shot of air, it opens up.
Okay.
The balls open up, goes around, balls go around, pull down, lock it. So a shot of air drops it down.
So air pressure keeps it down. So you need constant air pressure.
No, you don't. Once it's a single acting switch, so once you shoot it, it's done.
Okay, that's cool.
Disconnect it and it doesn't break.
Is that all in here then?
That's all in here.
Okay.
And then when you're ready to release, hit the release, it opens it up, and it's free to move at that point.
Cool.
So this is my fixture plate.
Yeah.
These are my studs. I can put my studs in the fixture plate, drop it down. Extremely strong, extremely repeat. The receiver bushing you see is chamfered in the back. So as the balls expand on the shank, they're coming out. On our fixture plate. This could be vise. This could be your fixture plate. We have the bushings for accuracy, and that allows this to repeat to within a half thousandth from setup to setup. So tightening that down and using a set screw, you're done your setup.
Yeah. And they just have to be finger tight pretty much.
That's all,
right?
because there's no force being applied on this. It's all the forces are down. And you want to talk about how strong they are. That's what he's using to hold the tombstone to the machine table, and then the base of the tombstone is being held to the table by ball lock shape.
Okay.
Four ball lock shape. But the base and fixture is now held to the base of the tombstone by four ball lock shape. So it's an extremely strong system.
If you could ever machine that hardened, you'd get a nice, really polished finish with it, right?
Yeah.
But it's harder to machine harden.
Exactly, and I have done it hard. Like I left 10 thou.
Yeah.
Milled them soft, and then I left 10 thou.
That's awesome.
Oh, I see how it really goes down. The max depth is like 100 by 5 So anything dark is shiny. Oh, that stayed there the whole week. Oh, okay. That's what I used to tell that big area around town.
So I've got time to go to one more place right now. I'm gonna miss the 5th place. I'm at Single Source Technologies right now. I've been recognized. Paul here, who works at SSD, right?
SSD Canada, yeah.
He watches Knife Making Tuesdays. Alright, so he's gonna give us a personal tour. So what is SSD? What do you guys do?
We sell, CNC machines.
Okay.
And that's it. We do engineering services, CNC machine sales, CNC service. As you can see, we're full of CAD CAM
Yeah.
system.
Is it machined to this surface finish?
Yes.
What material and what hardness? It says right there.
H13.
Wow, that's so shiny.
3 hours.
It's worth it though. Say that again.
I seen you on YouTube.
Ah, this guy too.
Yeah.
How do you get back in again?
I move this down.
You don't get your finger caught?
Yeah, using this thumb. In here? Yeah, just like that. And then the blade will move.
Cool.
Yeah. Nice. I got that one. I brought this one.
There's a part that's actually starting right now.
Oh, cool.
It's a staple. Instead of putting stitches in, that black part there.
Yeah.
So that's a mold, that part.
What's it made of? The staple.
Plastic.
Okay.
Plastic that dissolves inside the body.
Like over time until it heals? So it's like a medical mold then?
Yep.
That's awesome. Whoa.
This part's cut in 7 minutes, 30 seconds.
It's a lot of metal.
That's a lot to remove.
Yeah.
You can see it over here a little bit better. So
Okay, there we go.
This is most of the extras removed. All that's left is these 2 pieces. It's left in with these tabs so that the part basically doesn't break away inside the machine. Then you bring it out, you break these off, and you can farm it smooth and grind it smooth. And this is the leading edge of an aircraft.
8.6 minutes.
8.6.
That's crazy. 24,000 RPM. Whoa.
This one's a little bit different just because it doesn't have the holes along the base. Very high acceleration and deceleration on the axes, both linear and rotary, and just high general speeds. The first one we're going to look at is rapids. So,
Yeah, it's got like 2,000-inch rapids, right?
2400 and 1G acceleration. So I'm going to do a quick rapid of the linear axes. So it's just going to do a quick X and Y motion. And then now the rotary. So we're going to hit B and C at its max. Holy cow. Quick. And then for a machine like this, actually probably the most important part is you spend all your time cutting, so 5-axis simultaneous tracking of the coordinate system. So it's important to be able to do this at equal capacity.
Okay, yeah. That's fast.
And then this is a loop that'll just keep repeating.
It's really quiet too.
And this utilizes obviously a different pallet changer. This is a more traditional setup.
With a tombstone, yeah.
Yeah, so you have your tombstone and you bolt your fixture on. And this one we have also on the other side of pieces.
Oh, cool.
It's like a modular system, so you can move it up, move it in, whatever. And then on the other side, I'll pull it out. We have a different setup.
Are these titanium?
Yeah, they're titanium.
This
That's just it's an 18 steel. These are titanium. That's titanium, and the rest is aluminum.
I love titanium.
It's a tricky material.
Yeah. That's what makes it fun.
To something, the next step up would probably be like a hydraulic holder, but they're expensive.
Yeah.
So these mill chucks, they're still expensive, but they're good because you can get collets in different sizes. So it's basically a steep taper, and there's bearings in here, and you put your tool in, and you crank down on this, and there's a wrench in there, and you spin it till it hits the bottom. And this is as close as you can get to a shrink fit system.
Okay.
With shrink fit being best.
Yeah. Huh.
We've tried a couple of things. We have milk checks. We got some TG collets and some ER collets. But for cutting demonstrations, we always use shrink, but obviously it's prohibitively expensive. I mean, it's not something that you'd be doing at home or in a small shop.
Right. That's a sweet end mill.
Yeah, it's nice. There's a finisher, a titanium finisher.
Yeah. What size finishing end mill?
If there's a multiple of them. Okay. We have a 3 mil to clean it. I have a 2 mil to do some corner pick, and then I have a 1 mil just to go in and do some of the fine features in the corners and over on down in the valley here. It's actually a pretty good radius.
Can see it, the radius right there.
I use a 1 mil and I'll go back and forth on that. It's actually a pencil, so it's going around.
Okay. So it's not like you take. It's not like the smallest end mill is doing everything over again.
No. That's where the higher end machines are nicer because the blends, we call them tool blends, right?
Yeah.
It's way more efficient to have the bigger tool. If you can fit a bigger tool in, use a bigger tool, and then use the smaller ones to pick. But you need a fairly accurate machine so that when the two paths intersect, they're matched somewhat. So
and good enough cam, I guess, to do it.
Yeah, most of them have it. Even Mastercam has like what is it called, rest machining. Yeah. So you can just keep constantly bringing it down. Yeah. But we have in here, like we have this laser. This is a laser tool measurement system. So we run the tools at RPM, so 10,000 RPM or whatever it is, whatever we're running the tool at. So in most, the finishing one was around 20,000 RPM. So we'll measure the tool at 20,000. So we get all of the dynamic stuff in the spindle. You know, if it grows, if the tool's a bit longer. Just before I use it, I measure it, and that way the tool blends are a lot more consistent. And like I said, I think I have 7 tools on this whole part, and you can't really see any blends at all. There's no really, even this top piece and that radius, just up to about there.
Yeah,
there's one tool path. You can actually see it. You can see the line right there. Yeah, that's where it blends into another tool path down below. Blend, yeah. But it's you don't feel it. No, it's pretty good.
And what sort of end mills?
The maker is NS.
Never heard of it.
They're a Japanese. We actually sell them. Our consumables guy sells them. They're a high-end Japanese end mill, and the reason we like them is because they guarantee nose radiuses and stuff within microns. Okay. Because we program when we're doing mold parts. We don't program like cutter compensation. All we program it as I tell Mastercam that this is a 6 mil ball. Yeah.
Well, that was super cool at SST because at least 2 of the guys recognized me. They'd seen my videos, and that was just crazy cool. Love seeing that. But the machinists there actually talked their ear off for over an hour, and they told me a lot of really cool stuff about 3D machining and mold making and machining hard stuff and productivity with the machine and how to increase your cycle times. And it was kind of weird trying to film some of that, so I didn't. Because if I had a cameraman who filmed the 2 of us talking, it'd be okay, but if it's just me filming myself and another guy, it just felt weird. So I didn't really get to film any of those conversations, but I realized what companies like this do, they're the machine tool distributor, is they'll, if you're willing to buy a machine with them, they'll actually sit down with you beforehand and you say, okay, this is the part that I make, it takes me 10 minutes, I need it to take 1 minute, how do I do that? And then they can help you figure out, they're experts at figuring out how to increase the cycle time and or how to reduce the cycle time and just make the part faster and better and nicer and faster and awesomer and everything. And that's why they charge you money. But yeah, even just him telling me, not specifically for my business, but just in general, how they do this for other companies was very helpful to help me come up with ideas to help me make my knives even faster. Because, you know, that's kind of what I want to do, while keeping the quality exactly where it's at. So anyway, I've been at this for like 7 hours. I just went to 4 places. It was amazing. I loved it. If you ever get a chance to do something like this in your area, absolutely do it. I learned about it in the Canadian Manufacturing Magazine. Every country's probably got one. I know America has lots. So subscribe to that if you're not. And it's got all kinds of really cool information, and it advertises these kind of events. Yeah, so very successful day. I had a great time. I got to show my knives off a whole ton, which was kind of weird, but kind of awesome. Everybody loved them, and yeah. Alright guys, thank you so much for watching, and next video will be back in the garage machining cool stuff. Take care, bye.